Namaste, my name is Nisha and I'm a maths online tutor. In this video, I'm going to show you how to sketching graph of rational functions. And for this, we do these points. First factor, numerator and denominator, then find out intercepts, x-intercepts and y-intercepts. For finding x-intercepts, you can determine the zeros of the numerator, and for y-intercepts, you can put x is equal to 0 in the function. Vertical asymptotes, find the vertical asymptotes by determining the zeros of the denominator, and then you can check y tends to positive infinity or negative infinity on each side of each vertical asymptote by using test values. This is very important. And then horizontal asymptote, so find the horizontal asymptote if any, using the procedure described here in this box. Okay. And then you can find out some additional points as needed, and then sketch the graph. For vertical and horizontal asymptote, we can use this box, and we already done in my last video, so you know all these things, right? Here is today's question: graph this rational function and find out domain and range. So for this one, we have to find out factor the numerator and denominator. So 2x square plus 7x minus 4. Here x square coefficient is not 1. So we have to split middle term and use this method. Okay. So product is minus 8. 2 times minus 4 is minus 8, and sum is 7. We have to choose two numbers which product is minus 8 and sum is 7. So 8 times minus 1 is minus 8, and 8 minus 1 is 7. Here just split middle term, first term and last term right as it is. So 2x square minus 4, and split this one according to this 8 and minus 1. Okay. So 7x we can write 8x minus 1x means minus x. Okay. So from first two terms we can take common 2x. Here left x, here left 4. Okay. And from here we can take common negative, or we can say negative 1. So here all numbers mean sign change. Okay. So x plus 4. Now we can take common bracket portion x plus 4, and here left 2x, here left minus 1. Okay. Now we can factorize this x square plus x minus 2, and here x square coefficient is 1, so we can easily solve, right? Here write x, here write x. Here product is minus 2 and sum is 1. Coefficient of x is 1. So we have to choose two numbers which product is minus 2 and sum is 1. So 2 times minus 1 is minus 2, and 2 minus 1 is 1. So plus 2 minus 1. So we factored a numerator and denominator. We can substitute here. Okay. So Rx equal, here we can write this x plus 4 and 2x minus 1. Okay, now here denominator this x plus 2, x minus 1. Okay, now what we have to do? Okay, find out intercepts. So for x intercepts, determining the zeros of the numerator, and for y intercepts from the value of the function at x is equal to 0. For x-intercepts, find zeros of numerator. So x plus 4 equals 0 and 2x minus 1 equals 0. Okay, so x value minus 4 and here x value 1 upon 2. So x intercepts at minus 4 and minus 1 upon 2, positive 1 upon 2. Okay, for finding y-intercepts, we can put 0 in the given equation, and given equation is 2x square plus 7x minus 4 x square plus x minus 2. Now we can put x is equal to 0. So r 0, 2, 0 square plus 7, 0 minus 4, 0 square plus 0 minus 2. So here this 0 and just minus 4, here minus 2. Minus 4 divided by minus 2 we get 2. So y-intercept at 2. Okay, x-intercepts at minus 4 1 upon 2 and y-intercepts at 2. Okay, now find out vertical asymptotes. Okay, so for this we have to find out zeros of the denominator and then check this. Okay, your denominator x plus 2 x minus 1, so x plus 2 equals 0, x minus 1 equals 0. Okay, so x is equal to minus 2 and x is equal to 1. So x is equal to minus 2 and x is equal to 1, these lines vertical asymptotes. Okay, now we will check here which type of graph behave like y tends to plus infinity or minus infinity near to vertical asymptotes. So we approaches minus at minus 2 from left side and right side, and approaches at 1 from left side and right side. So we can take means values here and find out. So when we approaches from left side, so we will take like minus 2.1, minus 2.11, this type of values, and from right side minus 1.99, minus 1.999, like that. Okay, and here when we approaches from negative side, so we take 0.9, 0.99, 0.999, like that. Okay, and when we approaches from right side, so we take 1.01, 1.1, 1.11, like that. Okay, so this is the behavior near vertical asymptotes, and this is given question means rational function, and here a sign of y. So when we approaches 2 minus 2 from left side, so this one is negative, this one is positive, this one is negative, this one is negative. And when we solve, so because negative negative cancel, but positive negative is negative, so negative infinity means downside. Okay, and when we approaches at minus 2 from right side, so we get plus infinity. From left we are approaching 1, so we get y value minus infinity, and here when we approaches 1 from right side, so y tends to infinity. And now find out horizontal asymptote, and for that here you can see for this, if given rational function like that, so here x to the power n, here x to the power m. So which type of, here three conditions. So what is in our question? Here x square means n equal m. Okay, same this. So if n equal m, then R has horizontal asymptotes, y equal an upon bm. So y equal here coefficient of x square is 2 and here coefficient of x square is 1. So we can write 2 upon 1. Okay, 2 upon 1 which is 2. So horizontal asymptote y equal to. Before graphing, we have to find out some additional points. So we use the information we have found together with some additional values, these box, to sketch the graph. Now we can easily find out domain and range. So here domain we can put all values except -2 and 1. So x such that x not equal to -2 and x not equal to 1. And you can see here in the graph, range is all real numbers. Okay, so domain is this and range is this, all real numbers. So these questions really easy. You can just follow these steps, and this box is really useful, this one and this one too. But if you have any doubt, please ask me. And if you liked my video, so please like, share, and subscribe my YouTube channel. Have a great day.